So if we apply the interpretation of the derivative f of x as the slope of the tangent at x and f of x to the function f of x equals sine x, it appears that f prime, or derivative of f of x, is equal to cos x. That is, the derivative of the sine function is the cosine function. Okay? Which means that I have my max at, what is that? Whatever that point is, and then I continue, and then my derivative is the cosine function. Okay? Which means that if I were to draw my regular sine function over here, here, that would be the derivative. It's just shifted over to a certain point. And this would be y is equal to negative sine x. So the derivative of sine x is cos x. And as you can see, the function of cos x is just negative sine x shifted to the right by a certain amount of units. So now the rules to find the derivatives of sine and cosine are as follows. So the derivative of sine is cosine. The derivative of cosine, which we saw above, is just negative sine x. So the derivatives of composite sine and cosine functions. So this is if you have another function attached to sine and cosine. So if we have something like y is equal to sine, and then there's a function g of x, then the derivative is cosine, which is the derivative of sine, times that function g of x, and then you have to multiply it by the derivative of g of x. Okay? Or if sine of g of x is the same thing, it's cosine g of x times the derivative of g of x. Okay? And if we have cosine, derivative is negative sine, and then multiplied by g of x times the derivative of g of x. So we'll get through a few examples of these, which shouldn't take too long. So the first one is f of x is equal to 5 times sine of x. So we don't have any g of x function on the right side of sine x. So I'm simply just going to take the derivative of sine x. So my derivative is 5 times cos x. Let's start off pretty easily. Now my next one is f of x is equal to cos of 4x cubed plus 1. I want you guys to take the rule from the first page where it says that if we have cos and g of x, to take the derivative is just negative sine of g of x multiplied by the derivative of g of x. So who can tell me what the derivative of b is going to give us? Let's see. Yep, thank you, Priyanshu. So my derivative is going to be negative sine of 4x cubed plus 1 multiplied by the derivative of 4x cubed plus 1, which is just 12x squared, which gives me negative 12x squared times sine of 4x cubed plus 1. Right. Now we have our next one, where we have f of x is equal to sine to the power of 3 times x. So what this derivative would look like would be f prime of x is equal to, bring the 3 in the front, is 3 times sine x to the power of 2 times cos of x, which gives me 3 times sine squared x cos x. I'm just using my power of a product and then just taking the derivative of sine of x. And then the next one we have is y is equal to cosine times sine of 2x. This is the annoying derivative rule. So for c, we have sine 3 of x, or sine cubed of x. So all I'm doing is basically taking my power rule, which is basically saying I bring this to the front, which gives me 3. And then I take sine of x and bring it down to a singular power. And then I have to multiply by my derivative of sine of x, which is cos x. So for that one, it's basically allowing you to bring that power to the front, because I know usually sine 3 of x is different from sine of x squared. Or what could have happened is you can also just, in order to avoid this, you can just simply write, if you bring this forward, you get sine 3 sine squared x, if that helps anymore. No, it's not a 7. Oh. Should make my 2's better. And then for d, I have a composite function. So I have a f times g of x. So I'm going to take my derivative of my outside function. I got y prime is equal to, take the derivative of cos, which is negative sine, times sine 2x, multiplied by the derivative of 2x, which is 2, and then I just take the derivative of sine of x, which is cos of 2x. So now what I'm left with is negative 2 sine of sine 2x times cos x. And then for the next one, y is equal to 3 times sine x plus cos x to the power of 4. Again, I'm going to use my power rule and then take the derivative of my inside bracket. So I get y prime, putting the 4 down, is 4 times 3, which is 12, times sine x plus cos of x to the power of 3. Oh, my bad. Multiplied by the derivative of sine x, which is cos x, minus sine of x. And then for f, I have y is equal to x squared times sine of the square root of x. So again, here I have to use my product law. So we're going to be using that. So I have my p of x and my q of x. This would be p of x, and this would be q of x. So my p prime of x would be 2x, and my q prime of x would be, I could also write this as x to the 1/2. So I can get 1 over 2 x to the negative 1/2 times cos of square root of x. So which means that my derivative is going to be 2x times sine of the square root of x plus, we're going to get x squared times x to the negative 1/2, which means I get x to the power of 3 over 2 times cos of root x all over 2. Which means that if I were to simplify this, I would get y prime is equal to 1/2 x times 4 sine of the square root of x plus root x times cos of root x. Give you guys a chance to copy that, to copy it down for now. Yes, Priyanshu?
I'm a little confused. So when you pulled out the 1/2, I understood that you multiplied the first factor by 2, so you got 4x sine the square root of x. But where did when I did that, I didn't get rid of the x to the power of 3 over 2. I don't know how you made it into an x squared.
Well, that comes with exponent laws, right? Because when I do x
But
and
isn't
then
that factor already divided by 2?
which one?
The x to the power of 3 over 2? So if you're pulling out the half, wouldn't you leave that factor alone and just remove the division at the bottom?
That's what I did. With the 1/2, I removed the division, which is why I got 1/2 x. And then in order for me to get 2x sine of root x, I have 4 sine x plus root x remaining, because when I multiply those together, I would get 2x times the sine of the root of x. And then when I FOIL that back in, I get 1 over 2x times root x, which is 1 over 2x times x to the power of 1/2. And 1 plus a half gives me 3 over 2 again.
Okay. I might just be putting it into Desmos wrong. Okay.
No worries. So for the assignment, I'm really, like I said, not going to give you too difficult of a derivative to work with. So you would not have to worry about having anything too difficult to deal with. So we have our last two examples here. We have f of x equal to cos 4 times 3 e to the negative x. I'm going to give you guys that as try to do it on your own and then try to give me the answer by the end of class. The next one is y is equal to e times sine x plus cos x. So g, try to do that individually. So h is y is equal to e times sine x plus cos of x. So you get y prime is equal to e sine x plus cos x multiplied by the derivative of my exponent, which is cos x minus sine x. So again, try to do g on your own and try to figure that out by yourself. And now we're moving on to some word problems. So my first word problem is going to be find the equation of the tangent line to the curve, y is equal to cos 2x minus sine 4x at x is equal to pi over 4. So again, my y prime is going to be the derivative of cos of x, which is negative sine, times 2x, times the derivative of whatever's inside my bracket. The derivative of 2x is 2, minus the derivative of sine, which is cos of 4x, multiplied by 4. Which means I get negative 2 sine of 2x minus 4 cos of 4x. So now I need to figure out my tangent, the slope of my tangent when x is equal to pi over 4. So I'm going to get negative 2 times sine of 2 pi over 4 minus 4 cos of 4 pi over 4. which means I'm left with negative 2 times sine of pi over 2 minus 4 times cos of pi. So who remembers what sine of pi over 2 gives me? One. And what does cosine of pi give me? Nope, not positive 1. Negative 1. Cos of pi gives me negative 1, which means I get negative 2 plus 4, which is equal to 2. So this is the slope of my tangent. And now I need to figure out at what point that happens that in my original function. So I need to evaluate y at x is equal to pi over 4, which means I get cos of 2 pi over 4 minus sine of 4 pi over 4, which gives me cos of pi over 2 minus sine of pi. So I know cos of pi over 2 gives me 0, sine of pi also gives me 0, which means the points that I'm using is going to be pi over 4 and 0. And now I can find the equation of my tangent, which is y minus y1 is equal to m times x minus x1, which gives me y minus 0 is equal to 2 times x minus pi over 4. And I get y is equal to 2x minus pi over 2. So I said 0 is equal to 2x minus y minus pi over 2. If I want to get rid of that 2, I can just multiply both sides by 2. So I get 0 is 4x minus 2y minus pi as my equation in standard form of the tangent. And then last but not least, I find the local max and min of values of the function f of x equal to x times sine x plus cos x. So I need to figure out my derivative of f of x is equal to x times sine of x plus cos of x. So my first one is going to be, this is going to be product rule, and then this one I can just take by itself. So f of x, f prime of x is equal to 1 times sine x plus x, and the derivative of sine x, which is cos of x, plus the derivative of cos of x, which is negative sine x. Which means my sine x cancel out, which means I'm left with x times cos of x, and I need to set my tangent equal to 0. That's fine, Sebastian. So I have two roots. I have a root where x is equal to 0, which is fine because that falls under my domain. And I have cos x is equal to 0. When does cos of x give me 0? When it's between pi and negative pi. Pi over 2. So I get x is equal to plus minus pi over 2. So 3 over 2 is not included because it doesn't fall within my domain. So now let's take a look at my derivative function and how it behaves at those points. Because I'm looking for max and mins, I need to figure out my rates of change between all of those points. So from negative pi to negative 2 pi, if I were to sub in a number between that, I would get a positive value. If I sub in a number between negative pi over 2 and 0, I would get a rate of change, a increasing or decreasing interval. From 0 to 2 pi, I'm increasing, and from pi over 2 to pi, I am decreasing. Which means that I have a max that happens at 2 parts. I have a max at positive pi over 2 and negative pi over 2. And then I have a minimum at x is equal to 0. So now I need to figure out where my min is. So I have f at 0, sub it in for x, I get 1, which means my min is at 0 and 1. And then my two maxes, I sub in f at pi over 2 and f at negative pi over 2. And they both give me a value of pi over 2, which means I have max points at pi over 2 and pi over 2, and at negative pi over 2 and pi over 2. Well, because I'm looking for maxes and mins, I just need to use my derivative chart to figure out where I'm increasing and decreasing at. Okay, remember, my graph stops at negative pi and at positive pi, which means that I don't know what happens to the graph after the values of negative pi or after the values of positive pi.